Testing of DC motor, why we require, today we are going to discuss about testing of DC motors, that is DC missions. In case of generator, in case of motor, so many tests to be conducted to find efficiency, to find voltage profile, what is the generated voltage, what is the voltage drop. In case of motor, what are the tests to be required, what is the efficiency of a DC motor, how to find the efficiency and losses in a DC motor, all this will be found by using testing of DC motors. In case of testing is necessary for every instrument what we designed that will be sent to the market, because we are giving the warranty. Before sending the equipment or machine to the market, we required testing. Testing and quality assurance will be given by some manufacturers. That is, testing of DC motors is required to find the efficiency, to find speed characteristics, to find the losses. For all this we require test. What are the types of tests in DC motor? What are the direct method testing? Direct test and indirect test. Direct test means directly we are applying the load and finding the efficiency of motor, that is direct test. Whereas indirect test is without applying load, indirectly we are measuring the losses in case of motor, but that is indirect method. And another one is regenerative test. Regenerative test is nothing but Hopkins test. Why we are required testing of DC motor is required? To find the performance of the machine, to find the performance, how it behaves under no load, under full load, under off load, for different types of load, different type of load conditions, how the machine performs. If a machine purchased simply switching on, if a motor is purchased for our purpose, if you switch on, simply it is running. But when connected to load, suppose if we have purchased one induction motor, that is purpose is to pump the water. Without testing, if the induction motor is sent to the market, if you connect the motor to the pump, then if it gives less water pumping, then there is no use of that one. To give the performance of the machine, we need testing. To give or to find performance of the machine, we require testing of DC machine. To find the losses, if the motor is pumping the water with effectively, if the motor is running effectively, but if the losses are more, it gets heated up, because the losses will appear in the form of heat. In the form of heat, the losses will appear, hence we require find the efficiency of a machine and losses. If the losses are increased in DC motor, then what is the need of DC motor? Or if the losses are increased, they give more heat. The heat losses will be appear in the form of heat. It is very important. If you touch the motor, then it will give more heat if the losses are increased. The losses may be copper losses and friction windage losses, iron losses. After overcoming all the losses, we are getting some mechanical power output. To get this mechanical power output effectively, we have to find the efficiency of a DC machine. Where we have to use which type of machine. In case of DC motor used in traction, what is the efficiency of DC motor? If it gives low efficiency, there is no need of DC motor used in traction. In case of similarly, what is the quality of material? I already told you, if you purchase a fan, they are giving the warranty for 1 year. How they are giving the warranty for 1 year means they use different quality materials. The quality checking will be done. The materials used in stator, cast iron or cast steel, they are used in stator. The effectively good quality material, if they are used, the quality will be good, hence they are giving the warranty. If you go for local motors, then what is the disadvantage is they can't give the warranty. If you purchase a local cooker, gas Ganga cooker, like that, so many local cookers are there, but prestigious cooker is there. Prestige cooker, or if you go for another type, what are the other types of cookers we are using in pressure cookers? What are that? Pigeon, another one is Prestige. So many types of cookers are. They are giving the warranty for 5 years. For the cookers, they are giving the warranty for 5 years. How they are giving? In your home, you are using the cooker from last 5 years onwards. But if you purchase the local cooker, then they can't give warranty. It won't work for longer time, because the material used in the equipment. Similarly, the DC motor, DC machines give quality of the material. If they are used, they give better performance, better efficiency, better regulation, speed regulation, all this. Now let us start DC testing of DC missions. There are three types of tests present. One is direct test. For small scale missions, for small motors, we are going for directly by applying load. What is the efficiency we are finding? If the efficiency is poor, some losses will appear, some losses may be cause efficiency will be poor. That is direct method. Brake test. Brake test on DC shunt motor, DC motor comes under direct method. In direct method, we are applying directly load. In indirect method is nothing but Swinburne's test. Swinburne's test used to find the efficiency and losses, but no load. It is done on no load. The motor will be run on rated speed and rated voltage we are applied. After that we are calculating losses. How this test will be carried out, let us discuss. After that another one is regenerative method, regenerative test. Regenerative test, it is also known as Hopkinson's test. Hopkinson's method of testing. Motor generator set is required for this. The next is indirect method. Indirect method we are using, okay, now indirect method, or you did this experiment in the lab, the brake test on DC shunt motor, you did this experiment. We are using one DC shunt motor, a pulley is connected to a belt, it is applied a load. It is a direct method. For small motors or small missions, we are using this method, brake test of DC motor, suitable for small DC missions only. Hence, because it is a small DC mission, we can easily conduct this experiment or this test, direct test. It is loads on pulley adjusted with the wheels, the loads are adjusted, wheels. After that we are finding the voltage, rating, current and speed of this. After that, what is the load we applied, the spring balances gives the load. From that 9.81 into S1 minus S2 into force into radius gives some mechanical power output, P equal to 2 pi Nt by 60. We are using the formula. By applying this type of load directly to the motor, we are finding efficiency of DC motor. This is the circuit diagram related to finding the direct test or brake test of DC shunt motor. We are applying by using 4-point starter or 3-point starter, we are connecting armature field. After that we are adjusting, we are giving the rated voltage. By adjusting the rheostat which is in field winding, the rated motor will be speed, the motor will run at rated speed. After that we are taking these two readings, S1 and S2, we are calculating motor efficiency equal to the two readings S1 minus S2 into speed into radius into 9.81. That gives motor efficiency. Motor input power is taken from voltmeter reading, ammeter reading, product gives motor input, whereas motor output is given by S1 minus S2 into radius into weight. That is it is a speed of the DC motor, R is radius and 9.81 it is watts. By doing this experiment we are finding the efficiency like this, output by input gives efficiency. This experiment already in the laboratory. Coming to the brake test should be sufficiently tight for DC series motor. It should not be conducted brake test for DC series motor. The brake test should be sufficiently tight for a DC series motor. It is very difficult to conduct a brake test on DC series motor because it requires heavy load to conduct the experiment, and disadvantages are there. The size of motor is restricted. For small motors only we are using this method of testing, and spring balance reading are not steady, they are varying continuously. This method gives some, but efficiency will give approximately, not exactly. Next, Swinburne's test is the indirect method of loading of DC, indirect method of testing of a DC motor. The circuit diagram related to Swinburne's test is like this. Plus and minus is given to a 3-point starter by using voltmeter, ammeter. This voltmeter is connected across the positive and negative terminals, ammeter is connected line terminal. It is a 3-point starter. It is a F is connected to field winding and A is connected to armature winding. In Swinburne's test we are applying the rated voltage for armature, rated voltage by adjusting the field current we are obtaining the rated speed of DC shunt motor. By adjusting this field current we can adjust the speed of DC shunt motor, because speed is inversely proportional to flux, N is inversely proportional to flux. By adjusting the field current we can obtain easily What is the speed of DC shunt motor? After reaching the maximum speed, that is rated speed, we are taking the readings. From the no load readings, we are obtaining the efficiency. This is power absorbed by armature at no load is, we are obtaining that VL into I naught. VL into I naught gives no load power absorbed by the motor. Armature circuit losses is no load losses we are calculating. After that, no load rotational losses we are calculating. Vt into Ia naught minus Is square Ra, that is input power minus armature copper losses. If you copper losses minus chesamanukondi, input power lonchi copper loss minus cheste, remaining all constant losses, that is iron losses, rotational losses, friction and windage losses and iron losses, both are comes under constant losses. Friction losses plus iron losses, both will be constant. Shunt field losses can be obtained by voltage into shunt field current. Power input is obtained by V into IL. IL equal to Ia plus ISH, IF in case of DC shunt motor. By the use of relations, efficiency of DC motor will be calculated. That is Swimmer's test. At a different load also we can calculate. If the load current is very high, suppose the DC shunt motor load current is, maximum current is 10 amps. We can't apply 10 amps directly, but no load, under no load it takes 1 or 1.5 amps, then we can easily calculate the efficiency effectively in case of Swimmer's test, that is no load test. Next one. Some advantage, disadvantages of Swimmer's test is required very less power, that is very advantage. No need of wastage of power will be less in case of Swimmer's test, and since constant losses are known, efficiency of Swimmer's test can be predetermined at any, it is a predetermined. By without applying the load, we are calculating the efficiency. Predetermined efficiency is a Swimmer's test. Predetermined means before applying the load, we are finding the efficiency of DC shunt motor or DC compound motor, like that. Predetermined. Predetermine the losses of a DC shunt motor by using Swimmer's test. Some disadvantages are there. Iron losses are neglected in case of Swimmer's test. That is one of the disadvantages. It can be assured that the satisfactory communication load condition, we can't give surety will be less when under commutation loaded. We can't measure the temperature rise when the machine is loaded, because it is conducting in no load. The temperature rise all we can measure in Swimmer's test. These are the some disadvantages. In DC series motor, the Swimmer's test cannot be done, because DC series motor cannot be run without any load. We have to run DC series motor with load only, because torque is proportional to Is square. In series motor, torque is very dangerous, torque will obtain at the time of starting. Dangerous speed is obtained at the time of starting of DC series motor. Swimmer's test cannot be used for DC series motor. These are the some disadvantages. Coming to next is Hopkinson's test. These are motor and generator test. Motor and generator both are coupled together. In our laboratory also it is there, Hopkinson's test. How to conduct this Hopkinson test? All this will be two identical DC machines are required. One acts as motor, another one acts as generator. Two identical DC machines. Two identical DC machines are coupled together by common shaft. One acts as generator, another one acts as motor. For this, one of the two machines operated as generator to give supply electrical power to the motor. One of the machine acts as generator, another one acts as motor. Due to the drop in the generator output voltage, we need to extra voltage is required, that is supplied by another source. We require another source. The losses will be supplied from source. I told you when the train is moving, if you disconnect the supply, by using motor generator set, we can run the train up to some time only. Because of losses, the train will stop. I told you in the last class that when the train is moving, electric train is moving, by use of bow and conductor, bow collector, it takes the power supply. If we are using DC motor and generator set is coupled, if you remove the bow collector, then by the use of generator, we can generate power in train, again that will be supplied to motor. Again motor supplies mechanical power, again that will be connected to generator. If you run the train, after some time it will be stop, after some distance. కొంత దూరం వెళ్ళినాక ఖచ్చితంగా స్టాప్ అయిపోతుంది, ఎందుకంటే లాసెస్ ఉంటాయి కాబట్టి. ఆ లాసెస్ మనం సప్లై నుంచి ఇచ్చాం. ఇక్కడ హాప్కిన్సన్ టెస్ట్లో లాసెస్ అనేవి సప్లై నుంచి తీసుకుంటాయి. దిస్ ఈజ్ ద డయాగ్రామ్ రిలేటెడ్ టు Hopkinson's test. It is very important diagram. we are connected DC supply and two machines, identical machines, one acts as motor, another one acts as generator, and the two field windings are connected by using one ammeter and one rheostat. Two field rheostats are required for Hopkins test. Two DC machines, two DC motors are connected, DC machines are connected by using field rheostats, and ammeter is connected. A voltmeter is connected between two. First we are switching on that kit, after that we are switching on this 3-point starter. By simply varying the 3-point starter, run the motor at rated speed. After reaching the motor rated speed, see this voltmeter reading. If the voltmeter shows 0, then the potential across this is 0. At that moment we are closing. If you close, it won't affect. If the voltmeter shows some reading, we have to make this voltmeter to read 0. Then the motor generator set effectively work. This voltmeter is important to note that when it shows 0, then only we have to close the switch. Now the test will be conducted. Now extra power supply is required because motor is there, generator is there. Ee motor em chestadi, generator ku mechanical power istundi. Generator ee motor sambandhinchina input voltage istundi. Malla extra power enduku ante losses supply cheyadaniki extra power is required. Ee losses ni find out chesi manam efficiency kanukuntachu while working as a generator, while working as a motor. These are the input power to armature 1, motor armature circuit losses are I1 square RA, motor shunt field copper losses are V into IF, no load rotational losses in two machines are V into I1 minus two machines current into RA. Two identical machines, same armature resistance will be there. By this method, total motor losses is given by no load losses divided, but because we are using two motors, we are getting W0 by 2. We are dividing the losses of each machine can be by 2, we have to do. Okay. Like this, the efficiency will be conducted by using back-to-back test. It is also known as Hopkins test, is also known as back-to-back test, the another name for that. There are some advantages, disadvantages. Coming to the advantage, very less power is required because only losses we are drawing the power. Power losses will be less. Power తక్కువ తీసుకుంటుంది ఈ టెస్ట్లో. ఎందుకంటే మోటార్ జనరేటర్ అక్కడే ఉంటాయి కాబట్టి దానికి కావాల్సిన పవర్ జనరేటర్ ఇస్తుంది. జనరేటర్కి ఏం కావాలి? మెకానికల్ పవర్ కావాలి. మెకానికల్ పవర్ మోటరే ఇస్తుంది. ఇంకా రెండు మిషన్లో ఉండే లాసెస్ సప్లైడ్ బై సోర్స్ కాబట్టి తక్కువ పవర్ తీసుకుంటుంది. ఓన్లీ లాసెస్ మాత్రమే తీసుకుంటుంది. టెంపరేచర్ రైజ్ అండ్ కమ్యూటేషన్ కెన్ బి అబ్జర్వ్డ్. Temperature rise and commutation also can be observed. Change in iron loss due to flux can be observed. After that, disadvantages are difficult to find two identical machines. Two identical machines means same speed, same rating. That is very difficult, but we can easily conduct if the two machines are there. Both machines cannot be loaded equally at the time. Both machines cannot be loaded because motor and generator both cannot be loaded at a time. It is not possible to get separate iron losses for two machines. Separate iron loss find cheyam. Constant losses supply external source nunchi vacheve power supply antala vastha untundo, that is losses. Extra separate ga losses can find out cheyam. It is difficult to operate machines at rated speed because the field currents are very widely. These are the some disadvantages of Hopkins test. Each process is necessary for testing of different kinds of DC motors. Each process is necessary for different kinds of DC motors. Power required for direct method is much greater than in two other methods. Only direct method lo ekku power kavali, remaining methods lo power takkuva. That is indirect test and back to back test. No load rotational loss for particular machine cannot be determined separately only by indirect method. Indirect method lo direct ga no load rotational losses kanukolam. These are the some conclusions we from the testing of DC machines. These are the three methods we are using. The three methods also will be observed in laboratory.